Okay, so the next question that we have on the menu today is asking us what is the formula for the surface area of a triangular prism? Okay, so what is a triangular prism? I actually conveniently have a triangular prism. Um, so you see this calendar that I got here. I'll actually make my camera bigger so you can see better what's going on. Okay, so here I have my calendar, and here you can see it's a triangular prism. We have one rectangular side, another rectangular side, another rectangular side, a triangle side here, and a triangle side here. This is a rectangular prism, and if we wanted to unfold this, of course, like here we have holes on the triangle side, but just imagine there's like fully triangular sides that like can fold down, and we want to unfold this thing. We're gonna have a little something like this. So let me go back to the drawing. So this is an unfolded triangular prism. Okay, so we're going to have a couple of rectangles like this. They don't have to be the same size. And then we're going to have some triangles like this. Of course, we could have drawn the triangles other ways, but you know, this way is perfectly valid. Okay, so this is an unfolded triangular prism, and let's give some descriptions to some of these lengths. Okay, so the first length, let's put this in green. That will be constant for everyone. Is here. So this, let's say that this is the length. I just want to make sure that they use the same length here. Okay, yeah. This is the length. Let's put that with a cursive L. Okay, and we are going to have a couple of different slant sides because we don't know if it's going to be like an equilateral triangle. Like here on my calendar, we have an isosceles triangle, but we could have some like, it is possible that we have triangular prisms that have sides that have you know, those triangles have completely different unique side lengths for everyone. Okay, so let's say that this is going to be those two are going to be the same, which is going to be the same as those two that connect. So we can say that this can be, let's call that slant 1. And maybe in a whole new color, in blue. That will be the same as this one, which will be the same as this one, and that one. That can be slant 2. And our last one, let's put that in purple. Let's call that slant number 3. Okay, and that's going to be those two. And that one right there. Okay, so those are all going to be the same length. Okay, now these slants are, if you actually have a rectangular prism, it's fairly straightforward to measure them. So an example of a slant, I'll make my camera bigger again to show you on the physical model. Okay, so if I got my ruler here, you know, to measure a slant, that would be one slant, that would be another slant, and that would be another slant. These might be all different lengths for the slant, but it is what it is. Okay, I'm gonna grab that real fast. Ooh. And with a situation like this, measuring the length is obviously very straightforward. You just measure that out. Okay. Sometimes you won't be given the slants though, and you'll need to calculate them, and you can do that with a procedure like this. But let's say we do know the slants and we want to write an equation for this. So we know that the area of triangle which is base times height over 2. But we don't know the height of the triangle, right? Because the height of the triangle, we're only given the slants, which is not the same as the height. Okay, so well, another property that we're going to need, let's put that in orange, is the height, which is going to be from here to here. Okay, so that's going to be the height, and this is going to be the height. Okay, now as you can see, it's a little bit uncomfortable to look at when you have it arranged like this. But in general, you just want to somehow, some way, find the area of like these triangles individually, and then you know, once you have one triangle, you know the other. So like even though I drew the top triangle like this, and it's kind of like more difficult to visualize, it's really the same triangle as this one's, as the one on the bottom that's like pointing down. So once you find one, you found both. Okay, so let's just take the bottom one and not worry about the top one so much. And we know that the area of this triangle, let's actually label these sections. So this can be T1, or just T, because the triangles are the same. So T, and this can be R1, R2, R3. Okay, so so yeah, these are the 3 different shapes, and the total surface area is equal to R1 plus R2 plus R3 plus 2 times the area of a triangle. Okay, now these are all just the slants. So S2, S1, S3. So R1 is going to be S2 times L. This is plus S1 times L. This is plus slant 3. Yeah, S3 times L. Plus 2 area of the triangle. And the triangle, as you can see, is H base times height times 2. Base is equal to slant 3. S3, and height is equal to, well, okay, let's imagine this. Okay, so here we have H, and here we have like in total we have S3, so just halfway is S3 over 2. So get with the power of Pythagoras, we know the slant is going to be in this case, well, it also does depend on the triangle, but you would need to find the height somehow, some way. And in general, you're going to use that with Pythagoras theorem. So this is going to be one of the slants over a fraction of the slant. So this is going to be over 2 for an isosceles triangle. Let's actually use an isosceles triangle because that's just going to be easier for the calculation. But if you have like a more irregular triangle, you're going to need a more thorough investigation on that triangle. Okay, but regardless, all triangles can be analyzed by doing, or by breaking it down into two right angle triangles. Okay, so you will need, this will be very context dependent. Okay, and what I mean by all triangles can be broken down into two right angle triangles is, even if we have a triangle that looks as crazy as this, you know, that's a right angle triangle. If you can find that, you know, just finding the sum of those two triangles and adding them up, that's going to be the whole triangle. Okay, so let's see if we have any examples that we can add here. Suppose that we have maybe a prism, or let's say an example of, let's do a more simple example where we just have like an equilateral triangle based triangular prism. Okay, so we have, let's draw that out. Okay, and let's say this is our slants are all the same, and let's say this is our length, and those are going to be let's say that is 10 meters and the slant is equal to 3 meters. Okay, so if we want to break this down into finding the surface area, so find surface area. We could break it down like this. Okay, so we're going to have 3 rectangles, and we're going to have our triangles. Okay, we know that these are all the same length, and that's just 3 meters. And we know that right here, this is 10 meters. Okay, so this is our R1, R2, R3, and this is our T. Okay, so our surface area is equal to R1 plus R2 plus R3 plus 2 times T. That's a T as well. Okay, so let's find the area of our rectangles, and they're all the same. So they're all 3 meters times 10 meters. So this surface area is equal to 3 meters 10 meters plus 3 meters 10 meters plus 3 meters 10 meters plus 2t. So the surface area is equal to 3 times 3 meters times 10 meters. That's 90 square meters. And that's just from the rectangles, and this is plus 2t. So this is just from rectangles, from our values. Okay, now let's get the area of T. Okay, so we have an equilateral triangle. We know that the base, this is 3, and we're trying to find this. Okay, we're trying to find the h. We know that this distance is actually, I'm going to draw this way more neatly. Okay, pardon me. Okay, so I'm going to draw this like this triangle right here. Much better, much better. Okay, so we know that this length, 3 meters, which means that perfectly halfway through here is 1.5 meters. .5 meters. Okay, and this length right here, this is 3 meters, and we're trying to look for h. Okay, now we know from Pythagoras' theorem that h is going to be the square root of 3 squared minus 1.5 squared. Okay, so that's square root of 3 squared minus 1.5 squared, and that is 2.598 meters. Okay, and we know that the area of the triangle is base times height over 2 is t. Our base is 3 meters. Our height is 2.598 meters divided all by 2, and the area of a triangle is going to be that times 3 divided 2 is equal to 3.897 meters squared. Okay, cool. So now if we want to sub this t value back into our SA, so 90 meters squared plus 2t. We know that 90 meters squared plus, and we know that t is now 3.897 meters squared. We can add that up. Times 2 plus 90. And our total surface area is going to be 97.79 4 meters squared. And that would be our final answer for the triangular prism, this triangular prism with 10 meters and equilateral triangle based area. But of course, if you didn't have a triangular based prism, or if it was not an equilateral triangle, we would have different calculations, but you can see the general procedure. You want to unfold it, find the individual areas, add them up, and then you'll get your final answer. Okay, so in here, the above solution is good, or the above solution does not consider the case where there is triangle of the prism is has 3 unique side lengths. An example of the calculation process would be good. Also, would be nice to see the procedure of breaking down the prism into its component shapes to calculate the surface area of the individual sides before adding them all together. Okay, cool. So not sure if I'm too comfortable with this solution. I'll leave it at that. Okay, so I do need to wrap this up because time is a little bit tight in terms of things going on, but let me switch over my camera real fast. And so those are all the questions that we were going to cover today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button below and ring the notification bell. If you would like to submit your own questions, take a look at the links in the video description below, and remember to leave a like and a comment if you like the video, and share this video with your friends if you really like the video. This has been Millen from OneClass, and I hope to see you again soon. Goodbye, take care, and have fun with the mathematic magic.